Hello, everybody!
Hello.
Welcome back. Final week.
Final week already. Yeah. Time flies.
Last one. I know, I can't believe we've gone
Mm.
through the 3 weeks and we are here at the final week. Oh my goodness. So I think first of all we're going to ask, let's get some. I'm sort of going impromptu now. I feel exciting. I think we can do a bit of user participation, and depending on who's in, if anybody wants to say where they're from in the chat, and if you're super organised, can you give us the longitude and latitude of the town that you're in, and maybe,
Ooh.
ooh, maybe because this is a spatial one, so. Pop them in the chat. Put in if you. Let's see if we can get a couple of locations, and then we might be able to give you a live example of something whilst we're doing it. So pop them in the chat. But yes, we're in the last one, and let us know how you've been finding the channels, the challenges. It'd be good to know. Have you been finding them fun? Have you been learning something new?
Yeah, that would
Yes.
be great. I mean, you did give us feedback in the when you submitted your challenges, and the majority and actually everybody I think liked it. So we had like this rating thing, and 4 and 5 were the top ratings, and everybody really put in 4 or 5. So I think you did enjoy it, but it's always nice to hear
Mm.
um, what you thought about it, and what your feedback would be. So should we do this again next year? Was this fun? Was this interesting? Did you learn something?
Mm.
Did you had fun while learning something, which was the goal actually? And yeah, would you want to participate again?
Yes. Do you want to see a Summer of Nodes 2021?
Yeah.
Yes, hello everybody, hello. So we've got one, we've got
Hello.
one lat long, so we've got one longitude, latitude position, so if we get another one, or we can pick a few,
Yeah.
we can have
If
we
you, if
might
you don't
have a
know,
little bit of
maybe we should
fun.
tell people how to get this. I mean, you can go on Google Maps, I think, and pinpoint where you are, and do a I think a right click or something, and then you see
Mm.
then you see the
Oh,
coordinates.
I look at these, we've got loads of coordinates now, so we're going to have a bit of
Oh
fun
yeah,
with this
there I
later.
come.
Brilliant,
Yep.
thank you very much. Right, I think that might be useful data for something we can have a quick look at later. But without further ado, I think it's time to dive in.
Let's.
Let's do this. So as a quick reminder, for those of you who are new to this, Summer of Nodes, 4 weeks of challenges. This is week 4. This is the last week if you are going for the prizes. This is it. There is no more chances. This
No,
is
this is now or never.
now or never. Now or
Yeah.
never. Something for beginners and experienced alike. So we try to have something if you're a bit new to Neo4j. We've been building you up through the week. So we started you off with a data model. Then we got you to explore with Bloom. Then we got you to do some simple Cypher queries last week. And
Yep.
this week we're testing a little bit this week, but we've given you plenty of hints. So hopefully you should be pretty cool, and you should be able to do this. So again, you can do this. You can do this. We've got 4 challenges,
We're
and
confident. Yeah.
yes,
We believe in you.
you can do it. You can do it.
Yeah.
And hopefully you found this lots of fun, and we're hoping you've learnt some new stuff. So that's the goal of Summer of Nodes. So that was the quick reminder. Prizes. Last week, last opportunity, either to get a sticker or that fantastic, exciting, swag-filled bag. You got until Sunday.
Got until Sunday exactly, and then if you have, I mean, you will receive something, an email from me if you won, and send out will be happening after the whole thing is over. So next week.
Yeah. So yes, last chance. Oh, hello. We've got some more people joining us.
Yeah,
Fantastic.
and more coordinates. That's good.
I know. Oh gosh, we're gonna have to quickly hack those together. It'd be fun. It'd be good. So quick reminder of the schedule. So this is the last time we're going to be covering the schedule. So today, right now, we're doing the live stream. We're going to be introducing these challenges, and we're going to talk through the solutions from last week.
Yep.
And the blog post is already published, but we've got the blog post. And if you have registered, and you need to register if you want to have a chance of winning the prizes, we're going to send you an email with all the links and things so that you know where you need to click and go.
will be out in a while after
Yes.
this stream. Yep.
Yeah, fantastic. Then on Thursday, we will do another live stream, and we're going to give you some hints. So this is a perfect opportunity. If you have a go at this, you go, oh, I'm a bit stuck. Put any messages in the forum. So we've got a Summer of Nodes topic inside the Neo4j forum. So that's community.neo4j.com. So if you go there, drop your message. And again, if there's a common theme, we'll cover those as well in the hints to give you a bit more help. And again, we'll update that blog post. Oh yeah, and Alex has just popped the link in the chat as well. And we'll update that blog post after the stream. And then Sunday, this is it. You must get your solutions in by this point, otherwise that's it. We're going to have to wait until Summer of Nodes next year.
Yep.
So that's the deadline. Quick note, you can submit solution if you think, I think I didn't quite get it right. That's fine. You can keep submitting that form over and over again, and what we'll do is we'll take the newest answer that you've done, so the most latest one that you post, that's what we take as your answer. And you can do both challenges if you want to have a go at both challenges. You're welcome to have a go at it.
Have a go at it for sure.
Yeah.
And maybe just one more mention. I think there will be another stream next Monday, obviously to reveal the solution for this week's challenge.
Yes, so tune in for the solution, but we won't be giving you any more challenges.
Exactly. No more challenges, no more prizes. So if you want to take part, do it this week.
This week. Do it.
Yep.
Excellent. Oh, we're getting a lot of love from Satya. Pleased to hear it. You're doing a good time with the database.
Good.
Quick mention of the links. So we've got the links. Sandbox is slightly different this week because we're going to give you a bespoke sandbox to work with. But there's the blog post link. So you've got the blog post link. So that's there. And that's going to be the write-up of what we covered today. And for those of you who've missed this stream or you want to watch it again, we're going to have a link for it as well. So you'll be able to re-watch us in all our glory.
If you want to.
If you want to. Or if you want to pass it on to a friend.
Yeah.
Exactly.
I mean, you won't be able to win anything, but it's still fun to learn. So, yeah.
Exactly. Fun by doing.
Fun by doing, yep.
Absolutely. Right. Let's have a look at the final challenges. And I'm going to hand over to Alex.
Perfect. Cool. Thank you, Lou. So, this week's challenges will all be about spatial place and I almost wanted to say place in time, but place in on this planet, it's going to be a walkabout for the beginners. So we will beam you all to Central Park in New York City. It's a huge green lung of the city in New York, and has attracted over 42 million visitors in 2019. So this is quite amazing, to be honest. And I just looked at a couple of stats before. It is over 4 kilometers from south to north tip, and then I think 3.5 hectares big. So it's a huge space. You can cover on foot, and it's obviously you need much time, and you need good shoes to walk all of that. And not only is it the green lung of the city, but also is lots of points of interest column into this one space. So there is a couple of museums. So last week we talked about the week before last, we talked about the Metropolitan Museum, which actually is located at the edge of Central Park, but still would technically be part of Central Park. And also inside the Central Park is lots of many points of interest for walkers to enjoy and to look at. So this time we wanted to take you there based on the OpenStreetMap, and you will be a virtual tourist. You will walk virtually through Central Park, so your feet won't get tired. You can even ditch your shoes. You don't have to wear shoes. That's the beauty of it. And you will using Sandbox, like you said, as bespoke Neo4j Sandbox dedicated for this challenge. So it is a special one. And we have a couple of questions to navigate the park. So you will find out a few things, how to navigate locations with Neo4j, and how to explore a graph of a location in Neo4j.
Indeed.
Yeah.
So should we move on to the questions?
Yes, yeah, exactly. Let's move on to the questions. So here they are. Obviously, you don't need to write them down because the blog post will have them for you, and the blog post has also some information as well on how it all works. So you can read it up on there. But the first one will be your starting point. So where in Central Park do you need to start? Where will your point of first contact basically be? And the start point is a clock. And we would like to know what name is the clock, has the clock. From this position, we will find your next point of interest, and this is within 100 meters from a straight line from that clock you found. So you need to use the spatial functions. You will basically find this other point of interest from that clock, which is less than 100 meters away. And we would like to know how far away are they exactly in a straight line, and what's the name of this other point of interest, and the actual distance between these two, because obviously there's how the crow flies basically distance, so that's one distance, and then there's actually you need to use the path which the Central Park provides. You just kind of go across the lawn. It's not allowed, so go on the path. And for that, there's a distance you have to walk, and we would like to know that as well. And then because you're a little tired a little bit of walking, so now let's find a bicycle to rent and explore some further. And we would like to know, because you're thirsty as well and need a little bit of caffeine, is there a bicycle rental place for you which is close to a coffee shop? And then you need to tell us both the name of the coffee shop and the cycle rental location. And that's the questions we have for you this time. It might be a little bit tricky. You will find a couple of starting hints on the blog post already, but like Lou said, if you have challenges, if you struggle a little bit, don't worry about using the forums. We will answer your questions there, and obviously on Thursday we will give some more hints. But give it a go. Try your hand at it, and see what you can discover, and if you can find the answers to these questions.
Yeah, and the sooner you start, if you can, the better. Even just dipping your toe in the water, because if you have some questions, it's quite possible the questions that you have are questions that other people are having. So if you post them in the forum before Thursday, then that's something we can cover as well.
Exactly. Yeah, and then just one more thing maybe here is the veterans of you already know, but if you're new, we have a link for a form where you can submit your answers to the questions, and there is this link to the sandbox dedicated for this week's challenges. So please use that, because it has all the data already preloaded, so you don't have to load any data this time.
And it's worth saying as well, you have to use this link. If you just go to the sandbox, you won't find an option for OpenStreetMap on there. So you have to go through this magical link that will set that data box. So this sandbox is exclusively for Summer of Nodes Week 4. So you can't find it via regular means. And we had a mention on the slide previously about Neomaps. Don't panic. It's a great little app, and after we've covered both challenges, we're going to give you a quick demo of it, and we're going to show you how you can get it up and running and why it's so cool. So we'll be doing that in a second. Oh, and my apologies, I've forgotten to update your slide. So submitting the answer, you're submitting the form. So you're not doing anything with Bloom. Ignore that line. My apologies. I've done a bit of a copy and paste job there. So ignore the Bloom bit. We want just the answers. Okay.
Exactly, but you'll see it if you fill in the form. No mention of Bloom there, so don't worry about it.
Yeah, absolutely. Okay, right. So let's move on to the experience challenge. So we're hoping you enjoyed last week's challenge, where you dipped your toe in the water working with the graph data science library and the algorithms in there, because we're going to be doing a bit more of it. So we're going to be sticking with the Central Park data set. So you're going to be using exactly the same sandbox as the beginner's challenge. So we've got the same data in there. And again, you'll probably find the Neomap's app useful to visualize the problem. And we've got a link as well to Estelle's blog post. So Estelle is one who put together this fantastic app, and she's got an example with regards to how you might go about importing some data from OpenStreetMap using a Python library. So if you think, you know what, this challenge is great, and I now want to grab some data that isn't Central Park, I want to grab some data maybe local to where I live or some other famous landmark or area, and have a look in that blog post, and it shows you it's really, really simple way to pull the data in there. So anyway, so moving on to the challenge at hand. So it turns out you're on a bit of a mission today. So you're very keen to get through Central Park as quickly as possible. But it's a hot day and you want to be near spraying water things. Fountains. So what we want you to do is we want you to figure out a route so that you start from the first fountain to the last fountain. So you want to be able to find out what the total distance would be to visit all of the fountains. And this has to be an efficient route. So you're not going to be bobbing back and forth. We want you to find what would be the distance of the most efficient route of visiting all of the points of interest with type fountain in Central Park. And we want you to use the route. So no straight line as the crow flies. We want you to actually use the routes between the nodes. So what's probably worth quickly mentioning for both of these challenges, and I'm just going to quickly jump into post, is we have a data model for you. So if you do called db.schema.visualization, which we've been doing for the past few weeks, you'll see this and you might go, oh my goodness, where do I start? Don't panic. So don't need to worry about that. So what you want to work on, and this is in the blog post, this is the data model that is of interest to you. So very quickly, you'll see you've got an OSM node, and that contains two types of locations. You can either use the built-in Neo4j point, which has a property name of location, or you can use the latitude and longitude and use that. So choice is yours. Another thing to mention as well is that we have another node, so it's also an OSM node, but it's also got another label which is point of interest. So that's going to be your fountains, your cafe, your bike hire places and so forth. And as well as having these values here, it also has a name, so the name of the attraction or the point of interest, and a type, so type fountain, for example, or type cafe. That's all you need, and you'll notice here we've got the root relationship that joins these nodes, and you can see it's also self-referencing, of course, because it's all a 2OSM node. And here we've got the property of distance, and that's in meters. So that's what you're going to be using, certainly for the experience challenge. That's what you're going to be using to figure out the distances between the fountains. And one of the beginner's challenges where we're looking for the actual route between 2 points of interest. So that's the data model that you need to worry about. It's in the blog post. Don't worry about all of the bits and pieces you'd get if you called DB schema visualization. So that's the hard challenge. And so we talked about we want the minimum route, so a minimum sensible route between the visiting all the fountains. And you could theoretically brute force the answer. We'd rather you didn't. This is a fantastic opportunity to have a look at what's available in APOC in the GDS library. So have a look at the shortest path algorithms, for example, in the Graph Data Science library. Is there something useful that you can use there? So that's what we do.
Absolutely. I mean, brute forcing is not fun.
It's not efficient use of your time.
No. Even the goodie bag, I mean, it might be tempting, but no.
Absolutely. So that's the experience challenge. And again, same idea. We'd like you to you need to use that sandbox because that's where the data is. And you can submit, again, same form as the beginner's challenge. It's the r.neo4j.com/sun-week4ans. So that's that. So what would be really good now is let's have a quick look at how we'd go about working with Neomaps, which is a fantastic little app. So I'm just going to switch over here. So I've got my OpenStreetMap sandbox. So I've already got that set up in Sandbox. And what I'm going to do now is I need to create a remote connection to this database. So you see this little down arrow here. So I click on this, and what you will see is you have got connection details. So something quickly to mention here: you don't have to use Neomaps. You can solve this problem without ever using Neo4j Desktop. So if you're like, no, I'm sticking with Sandbox, that's fine. You can do that. But if you want to have a play with Neomaps, and I think it's a good idea to have a look at it. This is how we get set up. So first thing we need to do is we need to basically create a remote database. So if I go here and click on add to database, I've got a couple of options. So creating a local database, that's when you set up Neo4j on your machine and you use it. But what I want to do is I want to connect to a remote database. So I'll click on that. And then I need to provide it some information. So I'm going to call this OpenStreetMap, and I need to give it a bolt URL. So if we go to Sandbox here, you will notice when I click that down arrow, I've got a tab here that says connection details. So all I need to do is copy the bolt URL here, and I just paste it in. And then I'm going to press next, and then I need to give it a username and password. So I'm going to press this button here. And on Sandbox, the username is always Neo4j. So I put in Neo4j. And if I come back here, I have got this handy information here. That's the password, and I can copy that. And I love the password generator for this. There are some really good combinations.
It's a good one.
Oh, absolutely. So I paste in the password there, press save. And if I click on connect, so that's just going to say that that's the database that I'm using. There we go. I'm now connected to the Sandbox. So if I wanted to use browser via Neo4j Desktop rather than on the Sandbox, I can just click open here, and this is going to connect to the database. So let's try again. So we'll set up browser onto the Sandbox, so I'll be able to use browser from here if I'm that way inclined. So I'll just give that a moment. Whilst it's thinking about it, there we go. So I can now use browser from here. And
obviously,
what that means,
the rules of Sandbox do apply. So
yes, 3 days.
Be terminated.
Yes, so you've got initial 3 days in Sandbox. You can extend Sandbox, so let's show you how to do that. So if you want to use a Sandbox for longer than 3 days, you will have an option here under Actions, Extend, and that will extend it for another 7 days. So you can get a total of 10 days. But if you don't do anything after 3 days, it will expire. So as Alex said, and it doesn't matter that you've connected via desktop, it will go. So be aware of that, as Alex very rightly said. So here we go. So this is the guide. So you've got some useful links in here to get you started. Now, the reason why we wanted to connect via desktop is so that we can use the graph apps. And the graph app in question that we're interested in is Neomaps. So I'm just going to show you now how to install that. So we've got a link for this in the blog post, so don't worry. But what we want is we want to get this link here. So I'm just going to copy that. And if I go back to desktop, if I click on this button here, this is where all the graph apps are. If I click on this, and I've got this option here to install, and I'm going to paste that link that I just copied and press install. And yes, I want to install it. And there you go, I've now got Neomaps. So what I can do now, because I'm now connected to the database, is if I click on this little arrow here, I can now open Neomaps. So let's do that. And pop it here so you can all see what's going on. And what's very cool about Neomaps is it allows us to, it basically pulls the maps from OpenStreetMap, and it allows us to visualize points and polygons and that kind of thing. So let's do an example of this. So I'm going to show you me setting up a layer. So I'm going to put in all of the, well, let's start with all of the points of interest in Central Park. So I'm going to call this points of interest. So this is my layer. And I'm going to use the points for points system in Neo4j. So what I say here is I'm going to select my node label. So you remember we've got OSM node and we've got point of interest. So I'm going to select that one. I'm going to tell it what's the name of the point property. So that's location, as you recall from the model. And you can also specify tool tip property. So that's when you click on a dot and it tells you some information. So I'm going to select name here. And then I'm going to click on update map. So I want markers. And look at that. So here, what we've done is we've added all of our points of interest in our database. We're now visualizing on the map. And where this becomes super cool, this is brilliant. So you can just straight away forget about the challenge, the amount of fun you can start having with this.
Don't forget about the challenge.
Don't forget the challenge though. But you can do that. Let's say I go, well, actually, I'm going to be a bit more bespoke because what I want, so let's say I'm thinking about the experience challenge and I want to have a look at all of the fountains in Central Park. Right, let's quickly show you the tooltips. If I click on here, look, see, I can see the name of that one there. I've got bicycle parking. Ooh, I wonder if that's going to be the bicycle parking we look at later. so you see, so you get the name. So that's really, really cool. That's a fun way of being able to take our graph data and visualize, that spatial data of our graph data in a really nice way. And let's say I go, well, actually, what I want to do is I want to visualize all of the fountains because I'm thinking about that experience challenge. So what you can do as well is you can specify a cipher query to show those points. So let's do the example with the fountain. So I'm going to do match, so normal stuff we normally do. So match f point of interest, type fountain, and I'm going to return f dot. So we have in this situation we have to always return latitude and longitude. So let's just do this. I'm going to do return f dot lat as latitude. So you always have to do it as latitude, as longitude, as tooltip for Neomap to pick it up. So f dot long as longitude and f dot name as tooltip. So you say what you want, and you can do conditional logic here. So if you only want to show points in a certain situation, you can do that. So what Neomaps wants is it wants you to return it a longitude, latitude, and a tooltip. And you can do whatever conditional logic in plain old cipher, or you can use the graph data science algorithms, or you can use APOC. And in fact, Estelle has got a blog post on how she does shortest path and visualizing shortest path. So that link is in the blog post, the week 4 blog post as well. So you can do this stuff. So here I've got the tooltip. So I'm now going to update map. And look at that. So now I've got, I've got all of the fountains. Aha.
Might
so
be
you can
interesting.
see. Might be very interesting, but you can start to see how this is going to help you visualize what's going on, and you can do lots of things like that. So have a play with that. You will find that fun. I'm just trying to think. Can we do a quick shortest path example? Just trying to think. So if we go, let's pick 2. I'm going to randomly pick 2 locations. So let's quickly do this. So let's do match.
We could, or we could try with the ones that the people in chat.
Oh yeah, we're going to do that next. We're going to do that next.
Okay.
But let's just quickly do this. So match p point of interest. Actually, we could have done this in. Let's do it like this. Let's do this. So p2 point of interest, where they're not the same because we don't want to match point of interest against itself. And let's do return. Actually, let's do where p1 is 0.2. Okay, let's do that, and let's do with p2 match path equals shortest path p p2, and then I think we want to do something like with nodes path as an S. So this is messy cipher that you can do this prettier. Unwind ns and s as n, and then if we do return n dot lat as latitude, n dot long as longitude, something like that. So let's just check that query runs. Oh, what have I done wrong?
I think you need to do more brackets around the shortest path.
I do indeed. I do. Oh, have I picked some crazy? I've picked some crazy path, haven't I? I should have picked something a bit closer. Let's just do something a bit closer. Let's do distance p dot location, p2 dot location is less than 400 meters. So hopefully this shouldn't be too crazy. Oh, you know what I've got to do? I've got to limit this. My bad.
Oh yeah.
This is now doing everything. Yep. So don't do this.
Everything, yes. Yeah.
Okay, so let's do limit 1. There we go. Okay, cool. So it does something. Now let's give it a whirl in Neomaps. So I'm gonna keep using the same layer because I'm lazy. So if we update this, we should get a bunch of points because these are going to be all the points that. Oh, that's nice. I like this. So if we switch this over to polyline, hopefully. Hey, look at that. There you go. So what we've done there is we've randomly picked 2 points in our 2 random points of interest that are within 400 meters of each other. And that's as the crow flies. So obviously you can see the route there is a bit longer. And then what we've done is we've then said, well, let's find the shortest path. So we're using Cypher shortest path here. You have weighted shortest path available in the Graph Data Science library, and you've also got one in APOC as well. So we're just doing this, and this will be the shortest points based on like the shortest number of nodes to get there. And then we've then extracted all of the nodes from there, so all of the different nodes that make up that shortest path, and we've plotted their longitude and latitude. So like that, we then put polyline on that, and we can see what that route looks like. So that's pretty
super cool,
isn't it?
That's
super cool.
Yeah.
You will have lots of fun with that. So have a play with Neomaps. It is a fantastic tool. And you've got all the links and various things that we mentioned. They're in the blog post, so don't panic. So that's Neomaps. That's how to get it set up on Neo4j desktop. So I guess probably time to look at some solutions.
Yep.
Fantastic. Right, let's minimize all of this. And back to the slides. So we've covered this week's challenges, so let's have a look at last week. Okay.
Exactly, yeah. Last week we did murder mystery, so you all had to get your thinking hats on and solve that murder. And the question for the beginners challenge was find the murder and find the accomplice and who did it and who set up somebody to do it. And I will show that now how it's done. So maybe quickly you should be able to see the browser. I have already imported all the data. I think I don't have to do this again. We showed this in the hints session from last Thursday, so I won't do it again. But what I will do is I will look for the schema again. So just to remind everybody what it was like, our data set. We had persons, and we had a couple of informations about those. They checked into events like Facebook events. They owned cars. These cars had obviously also license plates. They were memberships in this Get Fit Now gym. And this Get Fit Now gym was very advanced and had a digital check-in, so everybody could see, could check in themselves, obviously, I guess, via some kind of online tool. And this is the important thing. The police asked them about the murder and about information, and these persons, they had to give reports, and these were stored in the interview. And then there was also a crime scene report about that. So there was an interview about the person. The person gave that interview, and then there was a crime scene report about the murder scene of that specific date. What then? Obviously we ask you for a specific murder about the 15th January in Graphville. So what would have to go down is that we would have to find a specific murder report. So let's say we find that crime scene report, and the date of that report needs to be 2018, so in the year January 15, and the city of that report has to be Graphville, because that is where it happened, and the type of that report has to be a murder report. And then we would like to see that report. And then we only find one. I can click here to see the description, I guess. And then again, here you find all the information. So I'll zoom out of that, click on that, and expand that here so you can see it all. The report on 2018, 15th of January says security footage shows that there were 2 witnesses. First witness lives in the last house on Northwestern Drive. Second witness, named Annabelle, lives somewhere in Franklin Avenue. So we have 2 witnesses, names of 2 witnesses, and we can now find out who these persons are. So let's start maybe with the second witness, which we know what they called Annabelle, and they live somewhere in Franklin Avenue. So we go for it and say, okay, let's find a person where that name of the person contains Annabelle. So we know that there's something called something Annabelle, and the address street contains Franklin Avenue. So we also know, we don't really know what number they live in, but we know, okay, this is where they live, and they're called Annabelle something. So we see, okay, we found one person, so that's good. So now we can expand that node by double clicking, and we can see here, okay, she gave an interview, and we can click on that interview here and also read what she said. So we click here and we can expand here and say, okay, I saw the murder happen, and I recognized the killer from my gym when I was working out last week on January the 19th. So we know, okay, she was at the gym, murder was at the gym as well, because she recognized him from there, and she was there on the 19th. So that's another point which we then can store for later. Before we go into that, let's maybe pin that here and see what the other witness said. So again, we scrolling down here, we say, okay, the first witness lives in the last house on Northwestern Drive. So that's all we know. So we don't really know much here. So let's say, obviously we need to look for a person. So again, we know this. We know that this person is lives in a street, and that street is called or contains Northwestern Drive. Now we don't know how many numbers this Northwestern Drive has, how many people there are, how many houses there are. So let's pull back everything we know about the Northwestern Drive. So we go there by return, obviously, the name of that person, also the street address number, because then we know in which number this person lives, and we order this by the person, the address number in descending order. So that's why we know, okay, obviously the last house. Let me minimize. Oopsie. Let me minimize this one here. So we know, okay, here we get all the persons living in the Northwestern Drive, and here we have their address numbers. So we see, okay, Morty Shapiro here is our first hit, and he lives in the very last number of the Northwestern Drive, which is 4919. So we can now see, okay, we know that the Morty Shapiro is the other witness, and we can now find that other person. So we go by for that person, and we actually even know more about him than about the other person, so we can go in complete detail and can say, okay, we want to have the exact note, so his name is Morty Shapiro, and what I wanted, and we return that note of that person, and then we go here. Now we have the person Morty Shapiro. He also went to some Facebook events. He also has a car. But what's interesting for us now here is the interview, and we can see, okay, what was his testament? He said, I heard a gunshot and then saw a man run out. He had a Get Fit Now gym bag, so that's also what Annabelle confirmed, because she was also at the gym from a week before. And the membership number on the tag started with 48Z. Only gold member have those bags, so that's something only specific types of membership tier guarantees you. And the man got into a car with a plate that included H42W. So we know lots of things. So we know now that the man indeed who had this gym membership. So 2 witnesses confirmed that. This guy Morty even saw the membership number, which starts with 48Z, so that's clearly helpful. And he even remembered that the license plate of the car included H42W. So I think that's very helpful. So what we can do now is basically we can look for people that checked in on the via the digital check-in system of the gym on the date that Annabelle confirmed for us. So Annabelle confirmed, if you remember, if I scroll down, let me close those 2 wrong executed. Annabelle confirmed, Annabelle confirmed, where's Annabelle? Oh, here's Annabelle. Annabelle confirmed that she was at the gym on the 9th of January and did see the murder there. Oh, let's go into that. Let's get the Get Fit Now check-ins at specific date. So let's see here. This is basically everybody that checked in on the Get Fit Now virtual check-in on that date. So what we want to know is where the ID, that's the membership basically, starts with. It's another narrowing down, starts with 48Z, which was the basic, the one that Morty saw, that the membership ID tag starts with that. And we know what Annabelle confirmed to us is that the date when the murder was there was indeed on the 9th January, so basically a week before that. And then we want to see the now membership ID and the date when that was happening. And I don't get any number. Why don't I get? Let me see. Journey starts with 48Z and T-date equals. Well, I don't. This is wrong here. Obviously, this is not a string, but a number. All right, so here we go. So now I have these. This is the date. Obviously, on the 9th of January, 2 people checked in at the gym who had the gold status and who had probably an ID with 48Z. So here you see the one person 48Z, and this is their full ID. Here's continuous 7A. This other person 48Z continues with 55. So let's double click here and see who these 2 people are. It's a Joe Gamuska and a Jeremy Bowers. So let's see. We know further from what Morty confirmed, or what Morty gave in a testimonial, said he had a car, and that license plate included H42W. So let's see if any of these people has a car. So the Joe guy doesn't have any further information. Jeremy, let's see, double clicking here and expanding this further. So I'll expand this here for you so you can see it better. So we have more information here. So let's say, okay, here, let me get that information for you. License number. All right, so we have Jeremy Bowers, and he has a license, is a car, a Spark LS, and that has a license number, and that license number is 423327, which is the driver's license, I guess, but we don't know. We don't need a driver's license. What we need is the license plate, and the plate number is here at the car, and it has 0H42W2. So let's go back to what Morty said. Morty said the man got in a car with a plate that included H42W. So let's see if that is indeed the case. H42W are the central numbers of that, or central digits of that license plate. So he would be able to confirm that Jeremy is the murderer. So now we know that he had done it. What we don't know yet is who is his accomplice. So basically, maybe we can see, okay, then police took him in, and he then gave a testimony as well. And he said, by clicking here in the interview, he said, "Oh, I was hired by a woman with a lot of money. I don't know her name, but I know she's around 5'5" or 5'7". She has red hair and she drives a Tesla Model S. I know that she attended the Grooven Graph Gathering 3 times in December 2017. So now what we can do here is very easy, because he confirms that she attended the Grooven Graph Gathering. He attended the Grooven Graph Gathering, so we just, all we need to do is here, check here, okay, he checked in. Let's see if maybe this other person also checked in. So double clicking here and say, okay, other 2 people checked into the Grooven Graph Gathering. So it's a Tyson Oyard and a Miranda Priestley. And we can double click on both of these people and see if we have more information about these. So we know that Tyson drives a S4, which is not a Tesla, but Miranda Priestley drives a Model S Tesla. So that would confirm her. Do we know more about her? We have an address number, we have an ID, we have a social security number. I don't think we have her height. Oh, we do have her height. It's here in her license number. So height is 66. So I think this is what Jeremy also confirmed in his interview, that she's probably around that height, and she drives the Model S. So Miranda Priestley is the woman that basically tasked Jeremy to kill that person. And now we have our 2 victims, or not our victims, our 2 culprits basically here, and we can lock them up. And that is how you do solve the challenge from last week.
Fantastic, thank you very much. So I guess it'll be a good time to look at the experience solution as well. We haven't forgotten about the longitudes and latitudes that you've given us of the places. So that's coming straight after. We're going to plot those onto Neomaps so that we can see. And again, if you want to chuck in your longitude and latitude in for the mix, you've got about sort of 5 or so minutes whilst I'm going through the solution. So here's your chance. All right, so let's have a look at the experience challenge. So we wanted you in the beginner's challenge to find out who were the culprits of this heinous crime, which we've done. And the other thing we wanted you to do as part of the experience challenge was to think about, are there any other potential witnesses? So we had 2 witnesses, which Alex went through, but we want to find out, are there any other potential witnesses that we want to speak to? So maybe they saw something, got some location. And what we wanted to do in this challenge was, it's taking advantage of a bit of a fluke in the data. We wanted you to think about using weakly connected components to try and identify these potential other witnesses. And what we wanted you to do, so we said you could either just stick to Facebook check-in to run weakly connected components to try and find some potential witnesses, or if you're feeling a bit more sort of having a bit more fun, you could also use the check-ins as well at the gym, Get Fit Now gym. So that's what we wanted you to do. So let's bring up a browser. So I'm just going to do that. Oops, do that now. So I've got desktop. I'm going to now open up a browser. And we're going to remind ourselves of the data model. And what we're going to do, so the main goal of this was we wanted you to have a go at getting a graph projection sorted out. So get a graph projection into memory and then run the graph algorithm. So depending on whether or not you just stuck with the Facebook check-ins or if you included the gym ones as well, you'll get slightly different answers. That's fine, both are acceptable. The point is you had a go at creating a graph projection and then running the weakly connected components. So that was the goal of this challenge. So let's have a quick look at the data model. So what we want to do is, excuse me. So what we wanted to do is we want to create this thing that's what's called a monopartite graph. So what that basically means, you've got one type of node, and we want to talk about how that type of node is connected to itself. So what kind of ways? So that's given us the pattern. So we want to derive a structure of the graph that maps that. So what we want to do is we're interested in either Facebook events and we're interested in the Get Fit Now. And this was Get Fit Now checking for a specific date. So this was the date of when Jeremy was spotted at the gym. So that was the
9th of January.
Exactly, 9th of January 2018, that's the one. So we wanted that specific date for the check-in, and then you can do all of the Facebook check-ins, that was fine. So what we've got here is we want to do a graph where we do person connected to person because they're at the same Facebook event, and we want to do person connected to person because they're at the gym at that specific date. So that's what we're trying to do. So what I'm going to do now is I'm going to show you my query. So the first bit I want to do is to create my graph, my graph projection, and I'm going to be using a cipher projection. So as somebody suggested in the hints, and this is perfectly valid and acceptable, what you could do is you could do your crafting of the graph. So you may decide to create a new relationship between a person node based on those 2 relationships and then do a native graph projection. That's totally fine. There's more than one way to solve this. I'm using a cipher projection. So what I'm doing here is I'm going to tell the projection creator what exactly I want it to do. So with this, you always provide the name of your graph projection. You provide the nodes that you want to involve in your graph projection, and then you want to say how those nodes are connected in the graph projection. So here, my nodes, I want to return all person nodes. So here I've match p person, return ID. So you always return the internal ID. So I'm returning the internal ID for p as ID. And then the second part is the relationship. So here, as an example, let me put this on a new line so that it's a bit, you can see what's going on there. So we're not getting the linter recoloring things. So Here in the second part, I'm giving it two points to tell it about the relationship. So here's the first one where I'm saying I want you to create that relationship between people based on whether they were at the gym on that specific date. So that's what I'm doing here. So person has Get Fit Now membership, that was at Get Fit Now on this check-in date, that's connected back to member to another person. So that's how I'm creating that relationship. And what you do is you return the relationships as internal node ID. So again, you're saying which node is the source, so which node does the relationship come out of, and then you have target, and that is where the relationship point to. So for those of you who have used APOC virtual relationships, this is kind of the principle that we're using. So we're kind of saying, we assume this pattern that we've got here, just assume that's the one relationship that connects those two nodes. So that's what's going on there. And then what I did is I used a union because I've got two different things I'm trying to connect here. So I use union, and as long as what you're returning, so the arguments it's about, as long as they're identical, that's fine. And what union will do is it'll bolt them all together. So I've got union, and then same idea here. I want to know about persons who are at the same Facebook events, check-in events. So again, I'm saying here's the path, and I want to treat this as a virtual relationship between the two. So that's what the projection is going to push up. And here I am. So I'm returning the source. So where does the relationship come out of? Where does the relationship go to? And these are the internal IDs of the nodes. So that's what I do. That's going to go off and create my graph projection. So let's run that. Just give that a moment. And then I'll show you an example of just doing the Facebook event. So I'm going to do both of those. So don't panic if you went, oh, but that's not the answer. That's fine. We just wanted you to have a go at just creating a graph projection and then running one of the graph algorithms, or running weakly connected components. So let's have a quick look at my query that I'm going to run now. So here I'm going to stream my results. And what I'm doing, I'm using weakly connected components. I'm giving the name of my graph projection that I've created. And then here I'm going to return node ID. So that's going to return the node ID, which is the internal ID, and we can convert that back to a node. I'll show you that in a second. And the component ID. So this is going to say what components, what community does this node belong to, having run this algorithm. And then what I do here is, because actually what I want to do is want to collect everything together. So what I did was I'm going to order these by the biggest collection first, and the reason why will become imminent very soon is, so I do with ID, so I'm keeping the component ID because that's a handy way to group together different components. And what I'm doing here, so I'm using this GDS util as node. So what this does is this is going to take the internal ID that we've got from the node, and that's going to convert that back into a node. And then what I want to do is I want to pull the name from that person node, and I'm doing that as names. And then what I do here is I'm returning the component ID, I'm returning the names collection, and then what I want to do is I'm going to order this by effectively the community with the most number of names. So that's what's going on here. So ordering by the size of names as S order by S descending. So order it by biggest to smallest. So if I run that, so we'll give that a few moments. And if we have a look, we have a winner. So we can see here, we've got Jeremy, we've got Miranda, and then obviously we've got the original witnesses here as well. So we've got Annabelle Miller, we've got, where is Morty there? So we've got that, and then we can set, but then, you know, if you submitted, well, all the other names here, those are potential witnesses to work to. Yep, that's great, that's fantastic. And we can do that as well with the Facebook one. But something I want to quickly show you before we do the Facebook only example is you've got a monopartite graph already, projection you've created. It's person linking person to the events. So one of the things we encourage you to do, although it wasn't a requirement of the challenge, but you've already done the work of figuring out what that projection looks like, why not have a look at what happens? So a really fun one, and this is just the quirk of the data, So this isn't, you know, don't sort of think you go off and solve murder cases like this, but this is a flick of the data. But I had a bit of fun with this, and I did PageRank on this. So again, I'm calling PageRank, I'm streaming the results, and what I'm doing here is I want to stream the most, from highest to lowest, people with the high PageRank scores. So again, same idea, I'm converting the internal, so I yield a node ID in the score. So this score is what their PageRank score is, and I want their name, so I'm converting the internal ID back to a node, and I want to order it by the highest score. And, drum roll please. I know, it's exciting, and this is where you can have a bit of fun. So it's well worth having a look at how the data's connected, because it can be really revealing to understand how these things are working. And the reason why the weakly connected components works so well, an example it brings back all those people is because, they've got a common gym event or a common event, and what weakly connected components is just having to look at these like these simple connections and go, right, you're a community, we group you together. And you can see, and this is a fun bit with PageRank, is that Jeremy Bowers has got the highest score, so he's very well connected. So you can start to have a little bit of fun like this because, he's connected to the same, he's been at a gym event, so he's connected to a bunch of people there. He went to an event, so he's well connected there. So he's the most PageRank looks at not only direct connections, but things that connect to things that you're connected to, and that filters through. So that's a great bit of fun. So let's have a quick look at if you did the Facebook. Oh, it's very cool. I had a bit of fun with this, and I thought you could actually solve the murder with PageRank and weakly connected components. And there you go. So let's have a quick peek at if you just did Facebook check-ins only. So I'm going to be very lazy here, and I'm just going to reuse this query, and I'm going to call this graph 2. And you should drop your graph projections. I'm just being lazy. These are small graphs, but you should. And I'm just going to get rid of all of this bit here. So the person node's ID still stands. So all I'm doing now is I'm just reducing it down to the Facebook check-ins. So let's create that projection. I haven't pressed the play button. Excellent, so that was nice and fast. So again, I'm going to run the same query. I'm just going to change over to my different graph projection. There we go, and there you go. So there's your smaller set. So again, you've got the same idea. You've got the 2 witnesses, you've got the 2 culprits, and then you've got the 2 potential witnesses. So same idea. So some of you did just the Facebook only, some of you did the Facebook in the gym. Both are valid, both are fine. So you can see the 2 different data sets there. So that's a nice bit of fun. And you'll all be shocked to find out that if I run PageRank on this second graph, again, it's a bit of fun, and it's a good opportunity if you've got the projection already up, you can have a look at the other algorithms. Jeremy's number 1 again, so I'll just run that. I should have allocated more. I should have allocated a bit more RAM to this. That's all fine. It's all fine. There we go. And, where has it gone? I think browser's just a little bit slow, but it's all good. It's at the top. If you'll only let me scroll up to the top. There we go. Jeremy's still number 1. Very cool. So that's that. So that's the solutions from last week. So very quickly, I'm going to just keep this database open. So I'm going to, for a bit of fun, we're going to take Neomaps. So I'm not putting any data into the database. I'm just going to use some Cypher. But let's have a quick look at where you've, for those of you who've provided us with some coordinates of where you're based, let's have a look at how this looks on Neomaps. And I'll talk you through what I've done, because this is a bit of fun. So you can have a nice bit of fun with this app. So what I've got here, I'm going to, let's change this to Stream Viewer, oh, can't spell today, Locations. And I'm going to do me some advanced Cypher. So what I've got here is I've taken your coordinates that you've provided me, thank you very much. So I've got them for iCannon, I've got them for Iuntico and for Asteionix. So I've got all of your coordinates that you've provided me, and what I'm doing here, I'm just creating an array of these properties. I'm then going to unwind it as location, and then I'm, again, same idea, I'm returning the latitude and longitude, so making sure that they come back as latitude, longitude, and your names as tooltips. And I am going to now update the map. Oh, look at that! Hey! Ta-da! So there's exactly a lot of fun to be had with this. So do have a go at Neomaps. So